My name is Ivo Hrbáček. I'm from Czech Republic, and I work for a company called Actinet. Basically, we work with Czech customers, helping them with security solutions. And today I would like to discuss one hot topic from my perspective, and that is automation of firewall rule base. Because as we all know, and our jobs are changing, automation is now key concept to follow. So I will try to show you one practical use case where automation can help to save time with operation. And also we will discuss the general consideration why automation of firewall rule base can actually become an utopia. So, well, let's start with motivation. As I said, we all have a lot of things to do, so let's automate them. Why not? My personal start was something around 2015 when I worked for a huge company where we managed so many firewall clusters running on version 7730. And as you can imagine, with this environment, there was a huge operation stuff, and firewall rule-based modifications, policy installation, and so on. And we realized actually that it takes almost 1 hour every day to install all the policies we modified the previous day. So we decided to automate this because we wanted to save some time, in the morning to drink coffee in the kitchen and discuss the normal things, not just sit behind the smart console and click for install button. So we created the solution which was based basically on the Git, Bash, and dbedit, because in that time that was only possibility how we can actually accomplish that. And practically how it was working, basically when the administrator did some changes in the rule base, he committed the changes, or he committed what kind of firewall cluster was modified through the Git repository. And every next morning, the job actually took these changes from the Git repository and installed the policies. And about the data, well, we had to use the dbedit because that was the only way in that time, as I said, to extract the policy names for the clusters and so on. And that was 2015. Well, in 2016 Q1, the R80 version came to light, and with this version also the API came to light. So the automation work, started to be more easier for us. And we can say actually that from 2017 API, that's now standard. Every vendor use that, and we can finally basically work with data. Probably 2 years ago, I started to work for a customer where we manage the checkpoint cluster, which is acting as a outgoing non-transparent proxy, and we also handle the operations on that. So that means the modification of the rule base and such things. So it was really good candidate to automate this because, as I said, the checkpoint is acting just as a proxy. It's not streamlined firewall. So it was, let's say at the beginning, it was not, but it was quite easy to implement this automation solution. So I wrote some Python script, which is actually adding the rules into the policy. And that's what I will show you in the next slides and also in the demo. But before I started, and generally speaking, before every automation task, you should consider some general consideration. And first, let's say what is important, and from my perspective, what is mandatory. It's how the order processing and input data look like. That means actually how you get the order, what should be modified, and if you have some service desk portal or whatever, how the tickets flowing, to the administrators, and how the data which should be modified, that means IP addresses, services, URL application, how this data should be extracted, And personally, I'm dividing the automation task to 2 categories. The first one is semi-automation, when the input data are basically pasted manually to some script or to some web interface or to some Ansible playbook, whatever you have. That's also our case. And why basically? It is because it's quite complicated, because if you work for customer, every customer has own service desk portal where they are created the orders. We have also own service desk portal, so it's not so easy to extract the data, let's say, from the machine perspective, from the, you know, so that's our case. And the second one, that's of course the full automation, and you can imagine that as a way that actually you have some service desk portal, whatever. Today, it's very popular, service now, Jira, whatever. But you can implement some logic from code perspective on the service desk portal. I mean the validation, app security approval, whatever. So everyone who is actually creating the ticket for some change in the firewall rule base can put there the data, and basically we can use something like middleware API, let's call it middleware API, which is doing the job. So we don't need to put the data manually to any script or whatever. So that's of course, the best way, but it's not so easy to accomplish that, as I will actually show you in the rest of the presentation. Another one good thing which should be considered is also security procedure for the new traffic. So it means how the security team is looking at the new stuff, like new server zones, new DMZ zones, new locations, and so on. That's also important, because you have to define the environment. If you have some strict zones, or if you have some, let's say, 0 strict zones, so that means how the traffic should be handled. If there should be some explicit allow in the policy, or if by default some environments have connectivity from the beginning to the proxy, and so on. Also, what is important when you are working on some automation task, it's if you are working on the greenfield, or if you have to do something in live production. Of course, in this case, our case, we started on the greenfield, so it was quite easier for us, because we had to create the policy structure, we had to create some logic. It may be sometimes complicated when you have the running environment, running firewalls with huge policies, 2000 rules. It's not so easy, but you can accomplish some automation. Why not? But anyway, let's move to the use case I have, and let's talk a little bit about the infrastructure. The customer, let's call it customer A, because I cannot be more specific. Customer A actually has some environment, and I can say it's actually a huge customer. And the main exit point to the internet is proxy. Of course, there are some exceptions which are defined. So some traffic may go to the internet directly. All is handled through the PAC files. But the main point is the proxy. So all the traffic going to the internet has to pass the proxy. We also define some zones, as I described. So in the environment, we have some strict zones where some special top secret servers, IoT devices, whatever. That means that by default, these machines don't have direct access to the proxy. You have to define the firewall rules before they can access even the proxy service. We have also some light zone where there are some subnets or zones, applications, which have also predefined rules with IP subnets and such things. We have also the user zones, where actually we are using identity awareness massively. So that means that all users with laptops and desktops using identity awareness agents, and the policy is defined on the with access roles. I have to say that there are other, let's say, gray zones, because as I said, customers is huge, so they also use something in the clouds, and with the clouds, the traffic flow to the internet is the same. It has to pass the proxy. So after these zone definitions, basically we created the unified rule base, and it has also some rules. As you know, probably when we are speaking about rules processing in the unified rule base, there are two phases. First one is that actually traffic to the proxy service itself has to be allowed. There has to be some TCP handshake, and after that, you can define application, URLs, and such a things through the policy. And some traffic has to flow, to identify the right application or right policy, whatever, and to uh, apply some threat prevention profiles and so on. So we created this structure, and we are also using some categorization. So that means basically that in the rule base, we use the URL categories, which are blocked by default. We are defining some block lists, allow lists, which is actually allowing or blocking the traffic. Also the IP rules, that's for the servers and machines which are agentless and don't have identity awareness agents installed. And basically that's from the infrastructure perspective. But we will discuss it more in the demo time. I will show you my lab, and you will see basically how it looks like. This is the picture of the policy. As I said, it has common structure, which is important for us. There are some sections, and basically we can say that we have something like allow section, which is allowing some particular traffic, but not all of them. It's named allow something, but block the rest. That means that some traffic is allowed on the firewall, but the rest is blocked. That's for the special use cases. Then we have allow list section where we allow the URLs or applications. Same with the block sections. Why this? It's because the section block category is basically may block or may allow traffic which is not needed. So we are able to restrict this. And after that, there are some sections which are, for the identity awareness rules and also for IP access rules. We will see more in the demo time. From the code infrastructure perspective, I have here two pictures. One is related to semi-automation. That's our task. That's our case actually, and how it works in this case. When the new order came to the service desk portal, with some modification of the rule base, the admin take this ticket and extract the data. What should be allowed? What kind of application? What kind of URL? It's based on the Excel sheet right now, so that's why we use the CLI version. When we extract the data, we can use the script to put all the data into it, and there is some logic, of course, which is downloading the rule base, checking if the particular application or URL is not allowed, and once it's done, the post changes are basically on the management side, and the new policy is loaded on the gateways. The second picture, the full automation, that's my vision for the future, because nowadays, as I said, we have to define things manually into the script. So we automate, but we don't fully automate. And in the future, I think that actually there is a good chance that there will be use case, or there will be chance with the customer. We will integrate the service desk portal with some middleware API. So it means that the new order, when somebody create a new ticket, okay, allow me something to the internet, this application, Slack, whatever. The data are in the ticket. There is some logic. If the service desk portal is able to, program some logic, there is some logic which can be done. Actually, the data are exchanged between API interface, which is a middleware, and then then everything is like in the first case. So that's the vision for the future, let's say. To be honest, I have to say that in good circumstances, when we are speaking about automation of proxy operations, we are able to automate almost 99%, because the calculation and the checking what is actually allowed, it's not so hard. But we will discuss later another one use case. From code perspective, basically, it's written in Python. It has something around 2,370 rows. And I use the way that actually I have some control class, which is handling all the things like input checking and validation. What is actually heard of this solution, and I would like to mention that I have special class which is called connector, and this class is basically the main interaction with the checkpoint API. So through this class, actually, I am able to log in, I am able to log out, I'm able to do the publish, I'm able to send the command to the API, do the API call actually. So basically, it's not so huge, but there is some logic. So at the first, you have to download the policy. You have to construct the policy because if you work with Checkpoint API, you know that the first interaction, everything is based just on UID. So you don't have real data. You have to somehow get it. The first. Second, we are getting the list of possible application, which is basically just checkpoint application database. Then we are checking the rules, rule by rule, and trying to find if something what is actually in order is already allowed or not. And once there is once the checking is done, basically the new data or new firewall rules are actually pushed to the management server. I'm trying to, or I try to use some multitasking in this scenario because the checking of the rules, basically first you have to check if the application and URL is there, and also you have to validate if the IP addresses or IP hosts are validated. So that's good candidate for multitasking. So I choose the asyncio module from Python. Anyway, now I'm thinking that I will maybe probably rewrite everything to the Golang, because from the multitasking perspective, Golang, it's much more better language. And the future task, well, basically finish the web interface. So we don't need to interact with CLI, but we will just put data into some web application and hit the button. And of course, the greatest thing from my perspective, find some use case where we can implement the full proxy automation. So basically the administrator will just control the flow of the data, and one need to connect to Smart Console to push the policies, to create rules and such things. Well, so the demo time. Basically, what I prepared, I have here the replication of customer environment. So it is actually the proxy gateway, which is acting as a normal checkpoint proxy with threat prevention blades enabled. Management server, I have a copy of the policy. And as I said before, there are some sections, basically general section for management rules. That's normal. That doesn't make sense to go through this. But anyway, what I want to show you is a section with block categories. That's our use case. We have so many categories which are blocked by default. If you are, let's say, if you have strict environment, you can block everything just by adding the URL filtering object. So basically that means that you have to allow everything explicitly. So if you don't want to use categories, you can use also this. And then there is some block list section, allow list section, where you can define the rules which are allowing the traffic. Same with identity awareness section. There are rules with identity access, objects, and IP address rules, and so on. Yeah, so that is how the policy looks like. And now let's say jump to the practical use case. I have here the testing machine. It's a Windows machine, basically. Let's imagine that it's configured through the GPO from the AD perspective, and I have defined some pack file. I don't have it. I have proxy defined manually, but doesn't matter. And I want to go to the internet right now. Basically, I'm completely disconnected because in this case, I'm using the identity awareness agent to be able to connect to proxy. So first, I have to connect myself to the proxy. And once connected, I will get I will get the basic internet connectivity. Just a sec. Okay, so now I'm connected to the proxy and I can browse to the internet because, as I said, the first phase is to allow the proxy service itself. That is done by this rule. The second part of the test basically is that normally in the policy I have some categories which are blocking the news websites and also some media sharing websites. In our case, I wanted to test something with Losto and also something with BBC, which is the news site. And as you can see, I'm not able to connect to BBC right now because it's basically blocked. So you can imagine that the new case or the new ticket from the customer perspective is, okay, well, I have the users and they want to, or they need to go to some websites like BBC. It's not good use case from the security perspective, but it's good for us. The script itself basically is interactive, so it is asking few things, what you want to do, and the first thing, you have to log in, of course. I have to say that actually all the logic, everything like storing passwords and user accounts, it's not part of the application because we are using the we are using the management accounts. So first thing I have to do is to log in and put there some input data, as I said. We are using some ticket numbers for tracking. So basically the ticket numbers are written as a comments or rule names. So this is the first thing. Okay, I have a wrong format, so I have to use it again. And what is the second one, and that's just the beginning. Yeah, it's our use case, and as you can see, I didn't write the password correctly, so I was not authenticated at all. So I have to start again, put the basic data for the firewall rule, and once done, I have to choose what I want to do. And as I said, we have three main cases to put there: some allow rule, some block rule, or some IP access rule. So in our case, I would like to show you how I will put the application of BBC website. Actually, there is a chance that the application won't exist for some web traffic, so you can also define everything just by the URL. So at the beginning it will ask you the URL which should be actually put into the rule base as an application site, but this is not our case, so I will just hit enter and move on, and I will try to find something what is related to BBC application. What the script is doing right now, it's downloading the checkpoint application database to see actually if the application exists. If not, it will notify you if it exists, and you will see there's application BBC. It was found, so we will just hit enter, and actually the script will create the new rule which is having the special application side, or in this case not application side but application itself, and it will actually publish new rule into the policy. And as you can see right now, there is a section whitelist. Just do this one, or allow list, let's say. And the new rule actually is here. It was added by the script. And the second thing, actually, it is asking if it should install the policy. So that's another thing that actually you don't need to go to the smart console to apply the changes. So it will also install the policy for you. And that's basically how it works in our use case. So all the tickets, all the orders are handled by the script in this way. And of course, you can now focus more on the security. So you don't need to spend so many hours with creating the rules or clicking into the policy. Well, so I need to check what is now time. Okay. It's still installing. Once done, it will notify us, and basically that's it. If I will try to use it again, and I will try to put the same application with just a sec, I will write this. Okay, and now let's imagine I want to do something. Okay, I cannot even write the password. Sorry for that. Oh, what's up? Okay, so I hope this time it will be better. Yes, okay, so, and of course, if you do something like, okay, I want to do it again, or somebody will receive the same ticket with the same application with same URL, so it will try to use it again. The script is actually validating the data from the policy, so it should notify you that actually this is already allowed, and this should be okay. So, but it's not just for the application; it's also for the IP addresses and so on. Well, and because the time is moving on, I have to also move with the presentation, and this is exactly the second one. Example I would like to discuss with you, because during my research last few years, I realized that, for example, this use case with proxy is not so hard to implement, because the calculation on the proxy is quite easy. You just get the policy, you will extract the applications or URLs or IP addresses, and you will just compare with the new input data. That's fine. There is no so big deal. But what about the next generation firewalls, the normal firewalls, let's say, with unified policy, with inline layers, with application objects, and so on? That can be somehow tricky, let's say. And you can imagine, for example, the use case with one central DC segmentation firewall, which has huge policy, something around 2000 rules, for example, how you will actually decide where to put the new rule. Normally when administrators do it manually, they search for similarity. And there are cases, for example, with the DC segmentation firewall, where you have just one policy that you can use some calculation, some prediction. But of course, and that's why I actually call this session why it can become an utopia. If you have too many firewalls and too many policies, your infrastructure is huge. Actually, it's not so easy to find how the traffic is passing through. There are of course some companies we are let's say that they have products which are more for orchestration, but in the production I never see something like that working, because it can be much more complex, to define all the stuff. Yeah, but anyway, personally, after my research, I have to say that the key maybe in the input data. Yeah, so it means that actually you should describe the situation as much as you can, so if you know the infrastructure, you have something like service catalog, you know where your application lives, what location, what zone, what subnet. You can even define what firewall policy should be modified, but that's all based on the input data. But it's not so easy because it may be complex, the policy itself. Inline layers today are very popular application services, identity awareness roles. So it's not so easy to put the new role. But anyway, during my research, I use the use case when I have the segmentation firewall, and the policy itself is defined in old way. So we have the source IP addresses, destination IP addresses, and destination ports. Everything is based just on the IP addresses and basically on the numbers. So the motivation, how actually.
So can we wrap up? We're running a little over time here. So.
Yeah, I will be. Okay. Just give me 5 minutes and I will be done.
Yeah,
I hope.
Try to make it 2.
Yeah, sorry for that. So sorry, one possible way how we can predict new position in the rule base is that we can actually use something like machine learning, or not something like, but machine learning algorithms. From Python perspective, there are great frameworks and modules from SCI Kitler. So what I used in my research, I tried to use the decision tree classifier and key neighbors classifier to find the right position. Because these classifiers works with numbers, we have to define the features and labels. What does it mean, basically? If you are a little bit familiar with machine learning algorithms, the features, that's in our case basically the set of rules in binary format. So you will transfer the source, destination, and protocol, port, and even action to some number, and the labels basically are the rules positions. So that means that actually you convert the policy to some format which can be used with classifiers. Only problem I found nowadays that the rule-based verification changed a little bit. So now probably there can be problem with similar rules. But anyway, once done, we can just fill up the algorithm and try to find the best position for new role. I have to say that actually this is just a theoretical experiment, because I don't have anything like this in the production. But anyway, I found that actually the results depends on the training model. That means that actually how much information about the rule you have, then the training model is better. And it looks that actually the key neighbors classifier is a better choice than a decision tree algorithm, but there are other things you have to consider, like, for example, identity access roles, because you are not able to calculate all the IP addresses which are behind the access role. It's not possible, because user can change the IP address. It's not about the IP address, it's about the identity. Same with application services. How will you describe these actually? You have to have some convert table or something like that, and you have to convert all to the numbers. There is no problem with IPv6, because you can also convert to the binary IPv6 ranges, IP ranges, and net groups. That's also problematic. But anyway, in the easy example, basically, I took 4 rules and I predict the position of the new rule, and I will show you practically.
Thanks, Ivo. I'm not sure if we have time to go through all of this.
Okay, so
just since we do have Igor waiting to present now, but
I will just do the summary.
everything.
Yeah, I will just do the summary, and we can actually move on with another one presenter. So,
thanks.
Well, summary. So we can say basically, or I can say from my experience, that it was not so hard to automate adding rules to the checkpoint firewall when we have proxy only service. Same with perimeter. If you have perimeter with some proxy rules, or if you are running the proxy, it's fine. You can use it, and you can automate it very well with few lines of code. A situation with next generation firewalls may be quite complex, but as you know, automation is now the key. So you should start with that. And basically, I have to say that 2 years ago, I think the R&D introduced something like rule-based assistant. And I'm not sure if some development is there, but I'm expecting, that in the future, services like this, like described, something what will actually predict where we should put the new rules, will be integrated, in the management itself, because it's not so hard from my perspective, I think, if you have a data, of course. So, and well, that's all from my side. Sorry, it was quite, let's say, long. I'm sorry, but
No worries.
it's huge, and
It's all good.
Yeah.
So